Alright, so let's do this. Reading line graph. So we did all this. We did proficient, nice, ready to move. We got quiz 2. Level up the above skills and collect up to 160. Did we do the quiz? I don't think so. Did we do the quiz? I don't think so. So let's do this. Where are we now? Let's do the quiz. 6 questions, 26 to 33 minutes. Here is a dot plot. Here is a dot plot showing the number of snow days each year for Siladun. Fact of Here is a dot plot showing the number of snow days each year for Siladun Middle School. Okay. Number of snow days. I got 0, 1, 2, 3, 4, 5, 6. Okay, so what's this? Snow day. Here's the dot plot showing the number of snow days each year for Siladun Middle School. So this is 1 year, this is 1 year, this is 1 year. This is the number. So Shem was by distribution in terms of its clusters, gaps, and peaks. There is a gap from 7 to 9. There's a peak at 3 snow days. Nope. Peak at 1. So, is it safe to say from 7 to 9? Or is it from 6 to 10? I don't know, but I'm gonna go with this. Okay. So, Sharia noted the songs played on a certain radio station for 2 hours. The back-to-back stem plot shows the number of weeks that each song played has been on the radio stations. Top 100 songs lists for the hour beginning at 7 a.m. and the hour beginning at 11 a.m. So here's 11 a.m., here's 7 a.m. 0, 1, 2, 3. 20 weeks. 20 weeks. So this is 20 weeks. Okay. So the center of the 7 a.m. distribution is I guess larger. Is greater than. The variability in the 7 a.m. distribution is the variability in the 7 a.m. distribution, 7 a.m. variability. So does it vary? I think yes, it varies. Because now it's 3 weeks, yes, it's greater than. Okay. In a recent experiment conducted by the Department of Energy, I don't want to read this rubbish. Okay, I'm coming after it. Light bulbs were tested to measure how long they lasted. Each company submitted 20 light bulbs, which were turned on on and left on until they burned out. Here's, here were the results. All 20 super bright light bulbs burned out after exactly 1500 hours. First delightful bright light bulb burned out after 1200 hours, and one additional bulb burned out every 50 hours until they were all burned out. Okay, one of the pretty bright light bulbs burned out after just 16 hours. The other 19 bulbs lasted between 900 and 2000 hours. Okay. Which of the following is true? Choose all answer. The interquarter range of light bulb life for delightful bright is greater than the range for pretty bright for light bulb. So where's light bulb? Super bright light bulbs. Where's delightful bright light bulb? Pretty bright. So what is the of light bulb for delightful bright? Delightful bright is greater than the range for pretty bright. Not really. Nope. Super bright light bulbs have the smallest standard deviation for light bulb life. Super bright is the smallest standard deviation for light bulb life among the three types. I think this is, yeah. So bulbs burned out after exactly 1500 hours. So there's no deviation. It's all the same. No, it doesn't vary. Yeah, it doesn't vary. Right. Okay. Super bright and pretty bright light bulbs cannot possibly have the same mean light bulb life. Super bright and pretty bright cannot possibly have the same mean light. I would say yes, because, well, it depends on the mean and what is the other thing? So if we consider this, what did they call it? If we consider this, I forgot what they call it, but meaning this is all alone on the left, all alone. I forgot what they call. The distribution of the delightful bright light bulb life is skewed right. Light bulb burned out after, and one additional bulb burned out every 50 hours until they were all burned out. Skewed right, not right. Skewed to the left. Outside. It's skewed somewhere. How it go? Okay, this is it. I got it. are positive. Yep. Yeah, I know. What do you mean? To contain the middle 50% of data, a greater range is required for delightful bright than for pretty for the delightful bright. It's greater for delightful bright. Wait, pretty bright, delight, delightful bright. Pretty bright. Wait, where is super bright? Delightful bright. This is delightful bright. It is skewed right. That's not true. Super bright helps lasted. Super bright and pretty bright cannot possibly have the same. Pretty bright. Super bright. Pretty bright is here. There is one here, so the mean could be here. 2000, 1000. But here it's 1500. It's 1500. So this is here. So this can't be right. This can't be right. This can't be right. What are we talking about? Where is that? And it's not skewed. The distribution of delightful bright is not skewed right. Delightful bright. Okay. Now, Nam owns a used car lot. He checked the odometers of the cars and recorded how far they had driven. He then created both a histogram and a box plot to display the same data. Three, 4, 5, 6, 3, 2. Which display can be used to find how many vehicles had driven more than 2000? The histogram. More than what? 200,000 kilometers. Distance. So this one. Okay, which display can be used to find that the median distance was approximately, I would say this one, the box plot. Let's check. Okay. Before sending track and field athletes to the Olympics, the US holds a qualifying meet. Before sending track and field athletes to the Olympics, the US holds a qualifying meet. The lower dot plot shows the times in seconds of the 8 sprinters. The lower dot plot shows the times in seconds of the 8 sprinters who competed in the final of the women's 100-meter dash at the 2012 Olympic Games. Okay, which pieces of information can be gathered from these dot plots? Were that lower sprint times are faster? طيب, the times in the Olympic final were faster on average than the top 8 US qualifier time. US qualifier 1, 2, 3, 4, 5, 6, 7, 8. It was fast. Yep. All of the times in the Olympic final were faster than all of the top. Not true. The Olympic final times varied noticeably more than the times of the top 8 US qualifiers. So what do we have? I guess yes, just by looking. Because let's say this is from, I don't know, 10 to 11, and this is from what? I don't know. Looks, yeah, goes here. 11 and 2, 11 and 1 dash, and here minus 10.7 and 4 dashes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how are we gonna calculate this? One, two, three, 4, 5. So 11.1 minus 10.75. That's 0.35, and here we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we got 11.111 minus, I don't know, 1, 2, 3, 4, 5, 6, 8, 9, 10, 9. Guys, this is fucking ridiculous. Let's just count them give them what they are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. This is 24, okay? And then here we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23, 24, 25, 26, 27, 28. So I got 28 here again. Here, what do I have? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Yep. Yep. Okay. Safia found this histogram. Which of these best describes the shape of this distribution? Skewed, right? Right, skewed. Okay. Lesson 3, what is that? Lesson 3. Yes, yeah, we have 2 more lessons. So let's finish with this unit.
Investment firm creates a graph showing the performance of a specific stock over 12 months. Over the course of the years, the price of the stock rising, falling, or staying the same. So over this axis right over here, the horizontal axis, they have month by month, and we move forward in time, July, August, September, October. And in this axis, the vertical axis, we have the price. So for example, in July, the price of this stock was a little over $10. Then in August, it moved up to, it looks like, around $11. And then we could keep going month by month. And this type of graph right over here is called a line graph because you have the data points for each month. And then we connected them with a line. And the reason why we connect them with the line is to really see if there's some kind of a trend here, to really show that that you have something that's moving from one price to another. And so line graphs tend to be used when you have something that's changing over time. Now with that out of the way, let's actually answer their question. Over the course of the year, is the price of the stock rising, falling, or staying the same? So on a month-to-month basis, you have, for example, from July to August, the price went up. Then from August to September, the price went down. Then it went up for 2 months. Then it went down for a month. Then it went up for a couple of more months. Then it went really up from February to March. Went all the way up to almost $17. Then it went down again. And then it kept going up again. But they're asking us not, did it go up every month? They're saying over the course of the year. Over the course of the year, is the price of the stock rising, falling, or staying the same? And if you go from July, which is where our data starts, right over here, our price was around $10. And even though there were a few months where it went down, the overall trend is that the price is going up. The overall trend is that the price is going up, and you can even see that. In July, it was $10, and then by June of the next year, it was approaching, I don't know, it looks like it's about almost a little over $16, maybe almost $17. So it actually had gone up a lot. They don't give us July of the next year, but the overall trend is definitely the upwards direction right over here. And you can see it just visually by looking at this line graph. Even though there's a few bumps that go down, the overall direction is upward. Thrill Soda hired a marketing company to help them promote their brand against Yummy Cola. The company gathered the following data about consumers' preference of soda. So they have year by year, percentage of respondents who preferred Yummy Cola, percentage of respondents who preferred Thrill Cola, and then these are people who had no preference. So in 2006, 80% liked Yummy, only 12% liked Thrill, and 8% didn't like either one or didn't have any preference. And so actually, just from here, you see that many, many more people liked Yummy Cola than Thrill Cola actually every year over here. So Thrill Cola definitely has something, they have an uphill battle. But then they said the advertising company created the following two graphs to promote Thrill Soda. And so let's see what's happening over here. So and let's think about whether this is misleading or not. So if we look at this graph over here, in 2006, sure enough, 80% liked Yummy Cola. Then 2007, 76%. Then it keeps going, then 77%, then 73%, then 73, then 68. So this is actually accurate data. It actually represents the data that's given right over here. I'll do it in the same. It actually represents this data very faithfully. Then right over here, if we look at this chart, percentage of people who prefer Thrill Soda. So over here in 2006, 12% preferred Thrill Soda. 2006, 12%. 2007, 19%. 2008, 19%. Then we go up to 20, 21, and 25. So the graphs are actually accurate. They're not lying. These are actually the data points of the percentage who prefer Thrill Soda. Now, what's misleading is if someone were to just look at these two graphs without actually looking at the scales over here, they'll see two things. They'll say, oh, look, you see a declining trend, and that's what line graphs are good for seeing trends. They say, look, I see a declining trend in the percentage of people who prefer Yummy Cola, and I see this increasing trend in the percentage of people who prefer Thrill Cola. And that's true. You have a declining trend here, and you have an increasing trend here. But what's misleading here is the way that they've plotted the scales. These scales are not the same. So when you look at this, you say not only is there an increasing trend of people who prefer Thrill Soda, but the way they set up the scale, that it looks like the trend is above. It looks like if you look, the human brain is tempted to compare these, and they say, look, not only is this an upward trend, but it's above this trend right over here. Even in 2006, this data point looks higher than these data points right over here. But the reality is that it's only because the scale is distorted. And this is the oldest trick in the book when plotting line graphs. It all depends on the scale. So this just looks good because they used this scale that went from 0 to 30 as opposed to 0 to 100. The better thing to do, or the more genuine thing to do, or the more honest thing to do would have actually been to plot them on the same graph. Although if they did that, that wouldn't have painted a very good picture for Thrill Soda. So if we plotted on the same graph, Thrill Soda, let's try that out. So in 2006, 12, and actually this is even worse. You wouldn't even be able to plot Thrill Soda on this graph because they started this graph right over here at 50%. They didn't even start it at 0%. So you actually would not even be able to plot Thrill Soda on this graph. If you did, you would have to extend this graph all the way down. So you would have to extend this graph all the way down to, so this would have to be 40, this would be 30, this would be 20%, this would be 10%. And then down all the way over here would be 0%. And then the Thrill Soda graph would be all the way down here. So it was like 12%, and it goes all the way up to like 25%. So the Thrill Soda, so it would have looked something like this. The graph would have looked something like this, which is nowhere near. If you plotted these on the same thing, on the same scale, on the same graph, then it would have still been pretty obvious that a lot more people, even though the trend is downward, a lot more people prefer Yummy Cola to Thrill Cola. So there's two very disingenuous things going on over here. One is the actual scale. For this amount of distance on this scale, they represent 10%. So whatever the gain is, it looks like it's a huge gain. And over here, that same amount, they're actually representing a larger amount. They're representing closer to 15 or 16%. And then the main thing is they started the scale here at 50%. So they're not showing how many people really prefer, how large 80% or even 70% really is. And over here they start at 0 and they just have a larger scale. So it makes it look like out the gate a lot of people prefer, or a comparable amount of people prefer Thrill, and that the trend is up. But the reality is still way more people prefer Yummy Cola. So this was a little bit, actually very, very not so honest way of representing the data. Or I guess you'd say they're misrepresenting the data.
Did you catch that he's actually showing you how to manipulate data? Well, if you guys happen to have a company one day, this is how you do it. This is how you manipulate data for press or for presentation at the at the level of the, what do they call them? Shareholders. So you got to do presentation for your product to the shareholders. You want to convince them to pay a lot of money. So you do this, manipulate. This is how you manipulate data. But what is this actually? Is there a manipulation here? Something we didn't catch? I didn't catch. But it's rising. Is that it? It is rising.
September, October. And in this axis, the vertical axis, we have the price. So for example, here is show when you have something that's $17 the same. The over
No
it was
manipulation.
approaching, I don't know, looks like it's about
Okay, no manipulation. Unit test. Let's do the unit test and finish with this unit. All set for the unit test. Welcome to the unit test where you get to test your skills for the entire unit. 12 questions, 12 to 24 minutes. Oh, excuse me, guys. I'm gonna have to, I don't know, take a break. Oh, not a break, not a long break. I'm just gonna get me some tea. The following dot plot shows the mass of each rock in Niger's rock collection. Each dot represents a different rock. The following dot plot shows the mass of each rock in Niger's rock collection. Each dot represents a different rock. How many rocks are in Niger's collection? Following dot plot shows the mass of each rock in Niger's rock collection. Each dot represents a different rock. So all these rocks. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many rocks? 10 rocks. I correct 2, 5, 8, 10. Okay. Summarize the number of drones sold by each Dragonfly drones location. Okay. Which of these best describes the shape of the distribution? I would say, since this is the mean, skewed left, not symmetric. At all, not symmetric at all. At all, not symmetric. Okay. St. Louis, Missouri. Okay. Missouri and Washington, D.C. have very similar latitudes. Latitude measures how far north or south a place is. St. Louis, Missouri and Washington, D.C. have very similar latitudes. Latitude measures how far north or south a place is. Latitude measures how far north or south a place is. which in turn affects the temperature. St. Louis, Missouri, and Washington, D.C. have very similar latitudes. Latitude measures how far north or south. Latitude measures how far north or south a place is, or south a place, which in turn affects the temperature. The box plots below show the daily high temperatures in degrees Celsius. Show the daily high temperatures in degrees Celsius that were recorded during July 2013 in each city. Fill the blank. Okay, this is larger than this. The center of St. Louis distribution is less. Is less. Well, the center. This is the center. It shows here. The center here is larger. Let's say that. Okay. The variability in St. Louis distribution is greater than, because look at this, from 20 to almost 36, 24. So here is a histogram that shows Anika. Anika's, do you know any Anika's, guys? Anika's scores from her last 30 rounds in a game. Anika wants to describe the score distribution in terms of its clusters, gaps, and peaks. So we got gap from 30 to 60. There's a gap from 30 to 60. What are we saying? Skewed left? I don't think so. There's a peak from 80 to 90 points. Peak, not really, from 70 to 80. The peak is from, okay, that'll be it. Okay, Kai is a wildlife photographer. The following data points represent the number of his pictures that have been published in each local newspaper. 463655. 463655. Using this data, create a dot plot where each dot represents a local newspaper. And the other ones represents the number of his pictures that have been published in each new local newspaper. 463655. So I get 4. Nope. I get 6. I get 2 6s actually. 6 and 7. Am I correct? 6 and 6. And I get 1 3. And I get 5 and 5. So how many ones? 1 2 3 4 5 6. And I got 6 here. Patsy the Peacock sells rare features. Below is the number of feathers she sold in each of the last 8 months. Using the data, create a histogram. So what are we having? From 0 to 5, just 1. Just 1. From 5 to 10, I got 1, 2, 3, 4. I got 4 from 5 to 10. And then from 10 to 15, from 10 to 15, I got 1, 2, 3. So I got 3, wait. I got only 2, 13 and 14. That's to 15. I got 119. So how many do I have? 2 and 2, 4 and 4, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Sal counted the number of songs on each album in his collection. He created both. Sal counted the number of songs on each album in his collection. He created both a dot plot and a box plot to display the same data. Sal counted the number of songs on each album in his collection. He created both a dot plot and a box plot to display the same data. Is that it? Which display makes it easier to see? The medium is 10 songs. Actually, the box plot. But let's give it a try. 16 minus 7, that's 8. 8 over 2, that's 4. So I got here 1, 2, 3, 4. Yep, exactly. How, man? 6, 5, 6, 7, 8, 9, 10. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 over 2 is 5. 1, 2, 4, 5. 8 and 8, 16. 8 and 8, 16. Am I correct, you guys? So 7, still 9. So it gives me 9. 9, 8. 16 minus 7. 16 minus 7. That's 9 over 2. That's 4.5. 2, 3, 4. It should be, I don't know. Okay. Which display allows us to see the mode is 10 songs? What do you mean the mode? Both. But I'll go with 10. 10. I would go with this one. I don't know what the mode is. The mode, I would go with the dot. Okay. Let's check it after. Okay, how many vehicles have been driven less than 200,000 kilometers? 200,000 kilometers. I got 3 and 4. That's 7. And I got 5. That's 12. And I got 6. That's 18. 18 vehicles. Okay. This is what I hate. In college, some teams get, doesn't matter. Some team get most of their points from just one player, and other teams are more balanced in scoring. Consider the following facts about the scoring distribution of some NCAA Division I basketball teams. Each team has 12 players. At Baylor University, There are 6 players who each score 12 points per game, and there are 6 players who each score 0 points for per game. At the University of Maryland, one player scores 58 points. The University of Maryland, one player scores 58 points per game. One player scores 14 points per game, and the rest of the players score 0 points per game. Okay, so at Dartmouth College, 4 players score 5 points per game. 4 players score 6 points per game, and 4 players score 7 points per game. Should we draw this just to be in the right? Should we draw this just to get it right for once? This question I hate, which I hate the most. The mean number of points per game for players at Baylor is Baylor. Where is Baylor? Baylor. So they got 12 points, 6 from 12 to 0. I'm gonna play it. I'm gonna write. It's from 6, from 12 to 0, so it's 6. Okay? The mean is 6. The mean number of points per game for player at Dartmouth. Dartmouth is from 5, actually from 7 to 6. Well, wait. From 7 to 5. From 7, 6, and 5. So it's 6 still. The mean is the same, is equal. Okay. The standard deviation for points per game for players at Dartmouth. Where are Dartmouth? And deviation is the standard deviation for points per game for players at Maryland. Maryland, where's Maryland? Steve Maryland, I got 58 per game, here 14, and the rest of players score 0. So, and I got Dartmouth players score 5 points per game, and I got 4 players score 6 points per game, 4 players score 7 points per game. So it's, I don't know, deviation. Standard deviation for points per game for players at Dartmouth. One player scores 14 points per game, and the rest of players score 0 points. So I guess, I don't know, it's not scattered around. It's probably the same because it's over 3. I would say the same. I would say equal. Wouldn't you say the median number of points per game for players at Baylor is the median number of points per game for players at Maryland? Remember the difference between the median and the mean? The mean is the average and the median The mean is the average, so I got number of points per game for players at Baylor. Baylor, I got 12, 6. Yep, I got 12 over, I don't know, each score 12 and 16 and 6 players. So I got 12, 12, 12, 12. I got 6. 6 on 12, that's 72. And that's it. Over how many? Over 12. Over 12. That's 6. That's 6. So I got 6 here. And at the University of Maryland, one player scores 58. So you get 58 and 14 over 12. So I get 58. 58. Wait, what's the next? Dartmouth. I got 5, 6. Okay, I got 4, 5 plus 4 or 6 plus 4 multiplied by 7 over 12. So it's still the same. 6. How about the median? Baylor is the median number for Maryland. So at Baylor, I got it still at 6. The median at Dartmouth College. Wait, where's the? It's Maryland. Maryland, I got 58 points. I got 4 points per game, 14 points. So 15, 8, and 0. I would go smaller. I guess this is Maryland. But here I would still get the median number of points. Play at Baylor 6, then the number of points at Maryland, which is seriously is less. I would say. God damn it. This I am sure of. What do you mean? Baylor. It goes from 12 to 0 over 2. That's 6. Whereas at Maryland, it's from 58 to 0. It's less. But the standard deviation points for players at Dartmouth per game. Maryland So this one we're not gonna get points for it, but let's get it. So I got 6, that's equal. I got that. I got measure how spread out the data are from the mean. So the means are the same. What do you mean? Is that this plot shows the distribution for points at Dartmouth. I know. At Dartmouth. Where's Dartmouth? It's less for per game for players at Maryland. Maryland's Maryland's it's like this from 60 to 0. So it's deviation. Or what do you call this? Is it because they are, what do they call it? It's not the same, it's less. So it's bigger, would you say? No, still less. Much less spread out at Maryland. So this, I got this correct. Okay. Here is the distribution points per game at Baylor. Since there were 6 players and 6 players who scored 0, there is no middle number. The median is halfway between these two values, 6 points per game. At Maryland, there was so many players who scored 0 points per game that this is the median value. The median is higher at Baylor. So this is it. This is it, okay. Not gonna get points for this one. Kama cleans dishes at Keith Cattle. The data below shows the number of dishes she cleaned in each of her 9 shifts over the last. Okay, using that data create a frequency table. I got 1, 2, that's it. 42, how many do I have? 42, 1, and I got here 1, 2. How many? 44? 1, 2, 44, also 2. And I got how many 45s? 1, 2, 3. What else? Is there anyone? Is there else? That's it. 3. And I got here 1. So I got 4, 6, 8, 9. And it's 9. Okay. A zookeeper created the following stem and leaf plot showing the number of tigers at each major zoo in the country. 0, 1, 2, 3, 4. Key to 25 tigers. How many zoos have more than 13? So here 1, okay, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Got 9. Baby 9. Again 3 and 4, that's 7, and 2, 9. Okay, this histogram below show the mass in kilograms of the offensive linemen on the University of Mount Union and the University of Alabama football teams. Which piece of information can be gathered from this histogram? The linemen who play for Mont Leon have more mass on average. Who plays for who? Mount Union. Mount Union. So I got 6. And here from 30 to 40 I got 8. So, and here from 30 to 40 I got 6. And I got 8 from 140 to 50. From 140 I got 4. Wrong. Wrong. All of the Alabama linemen have more mass. The Alabama linemen have more mass than all of the Mount Union. 120. All. Some of them have the same mass they got from 120. None of the above. Please. Okay. Well, that's it for this unit. So what are we having? Let's check our progress. Statistics and probability. I got unit 1. So this and this unit 1 and unit 2. We're gonna start unit 3 the next session, inshallah. So we're left with, I don't know, 14 units. It's gonna get interesting, I guess, later. Study design, exploring, summarizing quantitative data, modeling data distribution, exploring bivariate numerical data, study design, probability, counting, permutation, random variable, sampling and distributions, confidence intervals, significance tests, simple inference for the difference between inference for categorical data, advanced regression inference, analysis of variance. Test your knowledge of the skills in this course. So baby, it's gonna get interesting later because from here it's unit 3, mean, median and mode. Mean, calculating, and yep, it's gonna get interesting next, and the next from the next units. Standard deviation, I'm doing this for machine learning, quantitative and AI, quantitative sense normal distribution. Scatter plots, residual. Study design, statistical, reasonable samples, valid claims, types of studies, theoretical probability, example of all the ways sample spaces for compound. This is the probability I'm gonna face twice in the computer for okay for and the math for computer science at MIT and here. I'm gonna take it both. But where is randomness probability simulation? Discrete random variables. Okay. Ah, babe, going at stats on Khan Academy. Where did you say? Get interesting or ML, yeah, yeah, AI. Don't see where I said specifically. They may not have made that claim, or could they come? Don't have that. Rather, for relevance, here is roughly where course starts paying off. Early mid-course, genuinely foundational, don't skip. Probability basics, dependent, independent, conditional, probability. Standardized laterally, everything close functions, Bayesian method, probabilistic models. Random variables, probable and probability distribution. Cassine, especially the normal distribution, shows up in weight initial assumption, central limit theorem, just lots of stress. Mean variance. You already touched this in the reading theorem. 4.1's example. This is the backbone of loss functions. Batch from standardization, where it starts feeling directly Bayes' theorem about regression, linear regression especially, is arguably the single most direct bridge. Linear regression is the simplest possible ML model and understanding from a stats lens, residuals, least squares are maps almost onto how neural networks generalize the same hypothesis, testing p-values, confidence is directly ML but essential for evaluating whether models' performance difference real or noise. Show show me here. Part 1 to 4. Proof part 1 to 4. Minimizing the regression line. Part 1 to 4. Right. Unit 5. Unit 5. Exploring. This is the big one I meant. Now I can look at these exact topics in your list. Okay, by Unit 5. So Unit 5. The equation of regression line. Coefficient of the squared error of regression line. Proof part 1 to 4 minimize squared error to regression line. That last one, minimizing squared error, is genuinely the same math that trains a neural network. Only the same math that trains neural network. Gradient descent on a loss function is the generalized. Actually what you'll do by hand in Unit 5. Unit 7, probability specifically. Then dependence, calculating conditional probability condition. This is the direct ancestor of Bayes' theorem, the naive Bayes classified the variables mean, variances, discrete. Expected value shows up constantly in RL. Expected reward is function design distribution specifically. It's one limit theorem set. This is the theoretical justification for why many batch gradient descent behaves reasonably. So in terms of unit numbers, to where you likely are early, around 3 to 4, around unit 3 to 4 based on your recent notes. Unit 5, the first pick or the Zeman, then 7, 9, and 10 build the probabilistic. You're not far off. Unit 3 to 4 is exactly on. Okay, so MI here is there any missing topics I would need and yes, there are some real gaps since this is the statistics course, not a full math for ML curriculum. Here's what's covered well versus what's missing. Well covered by this course. Okay, missing, and these matter a lot for ML. Linear algebra, vectors, calculus, Bayesian inference beyond the basics, information theory basics, derivatives and gradients, linear algebra, vectors, matrices, matrix multiplication, dot products, engine. This is arguably the single biggest gap. Neural networks are fundamentally matrix operations. You understand what's happening inside model without this, not in this Khan Academy stat course at all. It's a separate KA course. Linear calculus, specifically derivatives and gradients, backpropagation, how neural networks learn, is literally the chain rule applied repeatedly. The stats course touches minimizing squared error but doesn't teach you the calculus machinery behind why that minimization works. You'd want at least single variable, but doesn't teach you. Wait. The stats course touches minimizing squared error, teach you the calculus machinery behind why the minimization works. You want at least single variable and ideally multivariable calculus, partial derivatives, gradients. Bayesian inference beyond the basics. This course gives you conditionality and Bayes theorem, but not the deeper Bayesian framework. Breyer's, post-Breyer's, MLE-Vis summation used in probabilistic information theory basics in entropy cross entropy KL. Shanti. Equations these show up directly as loss functions in classification models. Cross-entropy loss is the standard loss for covered anywhere in stats or in the discrete math course you're doing. Are there in discrete math you're doing now actually fills in some adjacent territory. Logic, proof technique, and later probability counting, so it's healthy overlap, not wasted. If you want, I can lay out a rough minimum stack for ML readiness stats plus calculus in what order, so you're not wait. I am planning for what do you call it? Linear algebra and calc, but the rest. So check this. Here we got check this. Good, this actually answers a chunk of what I flagged is missing. Let's check it against the covered by this course that I hadn't accounted for. Probability conditional, independence, random variables. This significantly overlaps with what Khan Academy Units 7 and 9 cover, but from a discrete combinator rather than a continuous stats angle. Really useful, complementary rather than redundant, since it will reinforce the conditional and expectation concepts from two different number theory, and something I mentioned before, but useful groundwork for understanding correct adjacent ML applications and modular arithmetic, which shows up in some ML areas like hash. Graph theory lectures 6 to 10. This is actually a real ML relevant. Gap filler I missed graph neural networks, knowledge graphs, and a lot of the underlying theory for representing relationships all lean on graph theory fundamentals. Still not covered either course, linear algebra, gradient, same already planned. Information theory, entropy, cross entropy, KL, still genuine gap, neither. Deeper Bayesian inference, priors, posteriors, MLE, probability lectures will get you conditional and independence will but likely stop short of full Bayesian inference as used in probabilistic. So the real remaining gap learnable later that would often just rather than a whole course you could pick it up from a single resource once you're doing actual and it become concrete understanding why cause entropy loss is used. So overall you're actually in much better shape than the list suggested quietly covers. Wait. I'll give. So what I have is another statistics. Okay, this one. So we got both covered. Okay, this one. And what do I have else? So are we in? Finish this today. Okay. What are we having? Pre-calculus. I got this. I got this. And I got. What are we in? What did I just submit? What is this? Wait. Wait. coming out. One thing worth flagging honestly: course details, current syllabus, whether it's still free. Okay, guys, that'll be it for today. Sorry for the inconvenience.